I am continuing the factoring series. The last video was on factoring trinomials. However, this one is factoring trinomials, but I want to go to a higher exponent. The last video was the quadratics, which stopped at the highest exponent of 2. But as you can see here in this example, my highest exponent is 4. So I'm still going to use the standard form, ax squared plus bx plus c, where a is the number that's in front of your exponent that's the largest, and c is your constant, which is the number that does not have a variable after it. For my guess and check, well, for all three of these, what I really would suggest is that you would factor out your greatest common factor first so that you're not dealing with large numbers. But I'm going to show you both ways, depending on the example that I'm working with. So for the guess and check, yes, let's just go ahead and factor out the greatest common factor. What do I mean? When I'm looking at my problem, I want to focus on the smallest number that's shown, because that number divided by itself is the largest number that can be divisible by that number. I hope that makes sense. So 4 is divisible by 4. That's the greatest number that I can divide 4 by. That's what I mean. But can I divide 14 by 4? No. So what I want to do then is I want to focus on only the factors of 4. So that would be 1 times 4 and then 2 times 2. Well, we just said 4 wouldn't work. So what about 14 divided by 2? Yes. What about 6 divided by 2? Yes. So I have just found my greatest common factor. So what I'm going to do with that information is I'm going to divide each term by that greatest common factor. That was the number portion. Now I want to look at the variable. I said I have a constant, so therefore that means I don't have a variable in that term. So therefore I will not have a greatest common factor that includes a variable. What I want to do is take that 2, which is my greatest common factor, and I want to put it on the outside of a set of parentheses. And what's on the inside of the parentheses is what's left over. So 6 divided by 2 is 3, and then I have an r to the 4th power. A positive 14 divided by 2 is positive 7, and I have an r squared. Positive 4 divided by 2 is positive 2. You would think you're finished, but you want to focus on that exponent, because maybe I can factor completely, which is what my directions will typically say. So that means I want to try to keep going. A common error is to forget to bring along that greatest common factor. So we just want to go ahead and bring that down right now so we don't forget. When I'm guessing and checking, I want to focus on my first term. What are the factors of 3? I know it's just 1 and 3. And then what are the factors of r to the 4th? Well, we're just going to use r squared. 3r squared times another r squared. If I multiply that out, that will be another way of writing 3r squared, r to the 4th. So then we're going to go to our c term, or the last term, which is 2. What are the factors of 2? 1 times 2. So when we're guessing and checking, what we're trying to do is determine, if I were to use my little happy face method, which one of these arrangements would end up with me adding to positive 7r squared, as well as multiplying to 3 times 2, which is 6. So let's just try from the inside out. So 2 times r squared is 2r squared. And then 3r squared times 3 times 1 is 3r squared. If I were to add that or subtract it, there's no way I'm going to ever get positive 7r squared. So I know that that is not correct. I know that the 3 times 1 is correct. I know that 2 times 1 is correct, but maybe the order is incorrect. So let's change it around, 1 and 2. And let's just say we're going to assume they're both positive. And they are. Let's see, 1 times r squared is 1r squared. 3r squared times 2 is 6r squared. And if they're both positive and I added them, I end up with 7r squared, which is what we were going for. And if I multiply the first and the last here, 3 times 2, then I end up with that 6. Are these factors, will they work? 1 times 6? Yes, they do. So just a side note, if I am working with a trinomial and I notice that the sign in front of B is a positive and the sign in front of C is a positive, this tells me that both of my factors will have the same sign and that sign will be positive. So that's what happened here. They both ended up being positive. If I have a negative in front of the B and I have a positive in front of my C, it's going to be the same concept, but both of them will be negative. So that was just a side note. There's a pattern that goes along with these trinomials. So that's my answer. I'm going to go ahead and write it at the top here. Let me make some room here. Get rid of that part. Okay, and then, oops, not that. All right, how about this? Let's just now try to get rid of this part and write my answer, which is including the greatest common factor. It's going to be 2 times the quantity of 3r squared plus 1 times the quantity of r squared plus 2. And if you just wanted to double check it to make sure, you can do a quick check. 2 times 3r squared is 6r squared times another r squared is going to be 6r to the 4th. And then 2 times 1 is 2 and 2 times 2 is 4. So again, you're just rewriting your answer as what, you're just rewriting it in factored form. All right, so my box, what I'm going to do is I'm going to go back to my original problem. And for my original problem, my A was 6r squared, 6r to the 4th. My last term was positive 4. So for the first box, I used the first term. For the last box, I've used the last term. I personally would have used this form if I were using my box, but I just want to show you in case you forget to factor out your greatest common factor, this is what it will look like. If you were using your greatest common factor form, this will go in the first box and this will go in the last box, and you would try to add to come to that positive 7r squared. But let's just say we forgot. So for my first term, I have the 6r to the 4th, the last term 4. If I multiply them together, that ends up being 24. I'm looking for 2 terms that will multiply to give me 24, but when I add them, they're going to give me 14r squared. So I want to remember that I'm replacing the 14r squared. So I'm going to go ahead and put my r squared here so I don't forget. And then if I don't know the factors readily, what I could do is just go to my calculator. I've shown you this before, but I'll show you again. Go to y equals whatever your A times C was, in this case, it was 24. Go ahead and type in that for your first line, divided by X. Go to the next line, type the same thing in, but this time add X. Go to your table. And what you're looking for in the third column is your middle term, which we said is 14. Make sure it is a positive 14 in this case. So because there is a negative 14 here, but that's not the one we're looking for. We want the positive 14. The factors that we need to put in box 2 and 3 are in front. So positive 2, positive 12. Doesn't matter which one goes where. So I'm just going to go ahead and put positive 12 and then positive 2. But again, it does not matter which order. Going to the left, I like to factor to the left. And what I came up with is the greatest common factor between, on the first row, between 6r to the 4th and 12r squared would be 6r squared. 6r squared times what will give me 6r to the 4th? R squared. 6r squared times what will give me positive 12r squared plus 2. And then I can just go, there's multiple ways to do this. 2 times what will give me 4 if I wanted to just go with my numbers instead of working with the variables. And then I would see, well, oh, that's positive 2. So now what I see is on the outside, I have factors. Move this out the way. And I'm going to write those factors down. I have the quantity of 6r squared plus 2 times the quantity of r squared plus 2. So the danger of not factoring out your greatest common factor is you'll think you're finished, but you're not, because there's a greatest common factor between those two, and it is 2. So I can pull out a 2. What's left over after I divide each term by that 2 is 3r squared plus 1 times the quantity of r squared plus 2, which is the same as the answer above. So I know I'm on the right track. For grouping, same thing. If I forget to factor out my greatest common factor, I'm going to have to do it at a later time, but it will, you will need to do it. So I'm going to take my first term. I'm going to leave some space, take my last term. And the reason I'm leaving the space is because I need 2 numbers to replace this 14r. And what are those 2 numbers? We just said they're going to be positive 12 and positive 2. So it doesn't matter which order. A few minutes ago, we did the 6 and the 12 together. Let's do the 2 this time. So positive 2r squared plus 12r squared. And again, it doesn't matter the order. Grouping means that I'm going to divide the first 2. I'm going to separate the first 2 terms from the last 2 terms, and then I'm just going to try to see what the greatest common factor is for each one of those. So for this first side, the greatest common factor is going to be 2r squared. Once I divide each term, I have 3r squared plus 1. On the other side, and I have to put it in order, I'm dividing by 4, and I have 3r squared left over plus 1. If I am on the right track, then I will notice that my new GCF will be what's shown inside of my parentheses, which is going to be 3r squared plus 1 times the quantity of 2r squared plus 4. Again, if I did not take out my GCF in the beginning, I'm going to have to do it now, because I notice that I can actually further simplify that. I can take out a GCF of 2, and I'm left with r squared plus 2 times the quantity of 3r squared plus 1. Same answer, I just switched the order. And it does not matter if you switch the order, because think about it. If you multiply 2 times 5, that's going to give you 10. And if you multiply 5 times 2, guess what? You still get 10. So it's okay to switch the order of your binomials. Let's see, example 2. So again, you really want to focus on taking out the greatest common factor, because these numbers are huge. You don't want to just be multiplying by 48 and negative 30, which I'm going to show you for those people that might forget. But you want to, if you see numbers like this, chances are you have a GCF. Always go for your smallest number, because that's going to be the number that the factors matter. So 36 cannot be divided by 30, neither can 48. So I'm just focused on the factors of 30. What are they? 1 times 30, 2 times 15, 3 times 10, 5 times 6. That's it, right? All right, so we just said that 36 cannot be divided by 30, 36 cannot be divided by 15, and 36 cannot be divided by 10. 36 can be divided by 6, so can 48. So that means that my greatest common factor is 6. Yes, 2, I can divide all of those by 2 also, but again, G stands for greatest, GCF. All right, so now what I wanted to do for my guess and check is go ahead and pull out that greatest common factor. What's left over is, once I simplify, 48 divided by 6 is 8m squared. 36 divided by 6 is 6m. Negative 30 divided by 6 is negative 5. I see that I have an exponent of 2, so chances are I could probably simplify this even further. I want to make sure to bring my greatest common factor down, and I'm going to focus on my first term. Now, I could try to do 8m. Well, it's guess and check, so let's just guess and check. So that's a factor. 8 times 1 is going to give me 8m squared, and then what's the factors for negative 5? I could use 5 and 1. Let's try that. And I see here that I have a negative sign. So what that means, and let's just go back to what I was showing you, the little patterns. So if I have a plus b and I have a negative c, this negative tells me that I am going to have different signs for both of my factors. The sign of b will go with the bigger number. So if I had 10 and 3, but I had a plus there, so the plus is going to go here, and the other factor will be different, and it's going to be negative. If I had a negative b and a negative c, same thing. I'm going to have different signs, and again, the larger number will have the sign of b. So this time 10 will be negative, and 3 will be positive. So it will always work that way. That's the pattern. That was just a side note for you. Okay, let's get rid of that and go back to what we were working with. So now I'm going to use my little smiley face method. In the middle, 1 times m is 1m. On the outside, 8 times 5 is 40. There is no way, I don't care how I manipulate the signs, that I'm going to end up with a 6m. So then let's try to change the 5 and the 1. Because we know we have the correct factors for 5 and 1, because those are the only factors for 5. But maybe the order's off. So now 5 times m is 5m, and then 8 times 1 is 8. Again, no matter how I manipulate the signs, I am not going to end up with a 6m. So that means that it must be, the problem must be with the 8m. It's not 8m. What are some factors other than 8 times 1 that will give me 8? Oh, sorry. I was wondering what was going on. I was like, nothing's disappearing. All right, let's get rid of that again. Come on. And this time over here, I am going to change, instead of 8, let's try 4 and 2. 4m and 2m. All right, so let's just try that and see what happens. So we have, if I'm going from the middle, 1 times 2 is 2m, and then 4 times 5 is 20m. Again, no matter how I manipulate that, there's no way that's going to add to equal 6m. And let's try swapping it around, putting the 5 first and then the 1. Okay, so let's see here. 5 times 2 is 10m. 4 times 1 is 4m. So if I add them, I end up with 14. However, if I use the rule that I just said, and I take my bigger number and I use the sign that's in front of B, and I know that they're going to be different signs because the sign in front of C is negative. Now, if I look at it, then 10 minus 4 is 6m, which is what I was looking for. And also 8 times negative 5 is negative 40. So if I took those two factors, positive 10 times negative 4, I still meet the criteria. So I just have to figure out where to put the plus and the minus, because again, I am multiplying 4 times negative 1, so therefore that will give me that negative 4. That is the correct answer. So let me go to the top again, get rid of this, and write our answer here. And if we're doing this correctly, no matter which strategy we use, we will end up with the same answer. So times the quantity of 2m minus 1. Let's try the box method this time. For my box, I am going to use this version because, again, if I use those big numbers, which I'm going to do for grouping, it will just be a big mess. So my new A term is 8m squared. And my last term is negative 5. I'm multiplying those two numbers, which I've already done over here. It's negative 40, and I'm trying to find two factors that will not only multiply to give me that, but they will add to give me my new B, which is positive 6. So we've already found that with our guess and check. And it doesn't matter which box goes where. So I'm just going to put the negative 4 here, but I have to put the m because I'm replacing the entire middle term, 6m, and then I have to put the positive 10m. So together, that's negative 40 if I multiply it, and when I add it, it's positive 6m. So that's my box. I am going to factor out to the left. That's just my preference. You can factor however you want. And when I factor out to the left, I see the greatest common factor is going to be positive 4m. Positive 4m times what will give me 8m squared? It is 2m. And then 4m times what will give me negative 4m, negative 1. And 2m times what will give me 10m. And if I'm looking at that, I see it's positive 5. So the sign that's closest to where you're writing is the sign that comes out, just so you're aware of that. And if I notice, I see that these are my factors. And I was already using my greatest common factor form, so I have to remember that I had a 6 there. So 6 times the quantity of 4m plus 5 times the quantity of 2m minus 1, which is what I have above. So I know again that I'm on the right track. And then finally, let's just go ahead and do this grouping. I've already multiplied it out to the side over here using the bigger numbers. So my grouping, I'm going to take this first number. I'm going back to my original because I forgot to take out my GCF. So 48m squared. Then I'm going to leave some space and I'm going to put negative 30. That's my last term. So I use my first and my last term when I'm grouping. That's all I'm doing, okay? So as you can see in the upper right-hand corner or up above, I multiplied 48 times 30, which is negative 1440. Well, that's huge, trying to figure out what the factors are. So again, I'm going to go to my calculator, second mode to get out of there. Now this time, my A times C was negative 1440 divided by X. Type the exact same thing, negative 1440 divided by X plus X. And now I go to my table, second, and table. What I'm looking for is my middle term of 36. So based off of the numbers, I see that I need to go upward. And I'm looking for 36. All right, there it went. All right, so over in my right-hand column, positive 36. If I look in front of it, those are my two factors, including the sign. So I see negative 24 and positive 60. So let's see if that works. Negative 24 and positive 60. If I multiply, it literally just told me that that's true. But what about if I add it? If I were to add it, and if you need to, go back to your calculator, second quit, and do negative 24 plus 60. And you'll see that, yes, it is in fact that middle term, positive 36. Signs matter. All right, so that's what I'm going to replace in the middle, and it does not matter which goes with which. What I'm focused on is, since I see a 0 there, I'm just going to go ahead and put that one with the 30. So negative 24m plus 60m, and then I'm going to divide those two. And what I end up with is taking out the greatest common factor, which is 24. I'm left with 2m squared, and this is going to be negative 1. Sorry. I apologize. I did that wrong. 24m. That matters. Both of them have an m. So make sure you see that. All right. So 48m squared divided by 24m is 2m minus 1. And then on the other side, I'm going to take out 30 because both are divisible by 30. And then I have 2m minus 1. Again, if I'm doing this correctly, my GCF is going to be the same in my parentheses. The signs and everything will look exactly the same. Now I want to pull that out, the GCF of the quantity of 2m minus 1. And what's left over, I'm going to put in its own separate set of parentheses, 24m plus 30. What I should notice is, since I did not factor out my greatest common factor in the beginning, I can now do so now. I personally don't like to wait this late because you might forget. So the greatest common factor between those two is 6. 24m divided by 6 is going to be 4m, and then 30 divided by 6 is going to be positive 5, and then you still bring down your other factor, which is 2m minus 1. Again, you see that you still have the exact same information. It was just different strategies for doing so. I hope that you were able to get something from this video, and if so, please thumbs up and subscribe. Have a great one.